Welcome all of you. So this is an ICSE topic that I have taken up, trigonometric identities from selina. Okay, so I am taking up this exercise from selina. This is exercise 21B. It's the last exercise that you find after just before complementary angles. Okay, last exercise of trigonometric identities. Okay, so I am going to take up a few questions from this, which is actually one type of questions. You will note that all the sums is of one type. Question 2. So we have to prove that, and what has been given is this part. Okay, so now let us start with the sum. Here you will see that the moment, how do we start with the sum? If you see x square here, make arrangements. So make arrangements to get an x square. जैसे भी हो x का square लाइए. Okay, that is going to help you. Okay, and also if you see m square, तो हम sum को उस direction में लेके जाएंगे जिसमें हमें m square मिल जाएगा. तो फिर let us square the first statement. What do you do? And what mistakes you can do, that also I will keep telling. So a square plus b square. Now sometimes people just write a square plus b square and they don't write that 2ab term. Okay, आपको 2ab term भी लिखना है. ये 2ab 2y sin a 2x cos a y sin a. This is my 2ab term. Okay, so a square b square plus 2ab is equal to m square. First statement. Okay, now let me write the second statement, which is x square, this one again. Okay, sin square a, that's my a, plus b square, which is y square cos square a, okay, minus 2x sin a and y cos a. Okay, that is equal to n square. So I have written square of this on both sides. So if I square this side, I will have to square that side also. Now note one thing, I have already got n square plus n square. So now here, okay, so see how I have written. The writing style मैटर्स. आप कैसे लिख रहे हो सम को, इससे बहुत फर्क पड़ता है. मैंने x के नीचे x लिखा है, y के नीचे y लिखा है, और ये जो 2xy टर्म है इसको एक दूसरे के नीचे लिखा है. ओके, तो अभी मैं ऐड करूंगी. आई विल बी एडिंग बोथ ऑफ देम, विच इज एक्स स्क्वायर देन cos square a plus sin square a. Okay, plus I am adding this y square sin square a plus cos square a. Okay, and plus this minus this, plus this and minus this. I will cancel it out because they are equal terms, they get cancelled out. Okay, is m square plus n square, then x square, because cos square a plus sin square a is a 1. Okay, plus y square, this is also 1. Okay, so that is equal to m square plus n square, hence proved. So दो ही statements में मैंने sum को complete कर लिया. Okay, m square minus n square is a square minus b square. This time it is with minus sign. Okay, it has come, m square n square has come with minus sign. So a tan a, b sec a sec b tan a. Yes. Okay, now I can see m square here, n square here. So I will square this. Okay, I don't have to think how I will solve it. I will just square to get my m square. Squaring a square sec square a plus b square tan square a. मैं कौन वाली आइडेंटिटी यूज कर रही हूँ, a plus b होल स्क्वायर का आइडेंटिटी, प्लस 2ab sec a tan a. Okay, plus 2ab sec a tan a. n square is a square tan square a plus b square sec square a, that is b square, plus 2ab sin a tan a sec a. Okay, so I have squared them and written them. Note one thing, a and a together, b and b together. Okay, so now I am going to subtract, because why, I saw a minus sign here, so I am going to subtract the two equations. n square minus n square, a square sec square a minus tan square a, okay, plus b square tan square a minus sec square a, okay. And then if I subtract this one from this one, they are exactly equal, so this sign will change to minus, full thing gets cancelled out. Okay, so I am not writing that. Here a square sec square minus tan square is a 1. Why 1? Because we know this identity, sec square a is tan square a plus 1. So sec square minus tan square is a 1 plus b square. Now here tan square minus sec square, if I take the sec square to the other side, then it becomes minus 1. So here it becomes minus 1. So I get a minus here. Okay. So this is a square minus b square. Hence I have got the statement that I was wanting, a square minus b square. Okay, so in the previous sum हमने add किया था, इस sum में हमने subtract किया. X square plus y square plus z square prove that x square plus y square plus z square is equal to r square. Let's see this sum. Okay, so now we have x square, we will make it x square. We have y square, this also square करते हैं. Z square है, इसको भी square करते हैं. Okay, तो फिर x square is equal to r square sin square a cos square b. Y square is equal to r square sin square a sin square b. And z square is equal to r square cos square a. Okay. I have only squared both sides of all the three statements. That's it. Now I'll add them. I really don't know how to complete the sum till now, but I've added it because I have to add it here. R square in bracket, then sin square a cos square b plus sin square a sin square b plus cos square a plus cos square a. Okay. So now this is r square. Now this is sin square a cos square b. I am taking the sin square a common from these two. Cos square b plus sin square b. This is the trick in this sum. इसको ध्यान से देखिए. sin square या बस यही दो टर्म हमने अभी लिया है, प्लस cos square b. इसको बस cos square a, इसको बस यूं ही लिख देंगे, अभी उसका कुछ काम नहीं है. r square and then I will, this is sin square a, okay, this becomes a 1. Why 1? You have to keep checking whether this both are b. If one is b, one is a, don't write a 1. Okay, don't do all that mistakes. And here plus cos square a, that is equal to r square. Okay, so r square, so x square plus y square plus z square has become an r square. We have proved it. Okay, this is our fifth question where we'll have to prove this, prove that. Okay, fifth question. So we will start from this. 1 by cos a plus 1 by sin a, okay, is equal to n. 1 by cos a plus 1 by sin a is 1. N. So sin a plus cos a is equal to n cos a sin a. N cos a sin a. Okay. Now this part is equal to m, you can see. So we'll put m here. M by n is equal to sin a cos a. Okay. M by n is equal to sin a cos a. We'll just keep this ready. We will square the first statement now. Sin square a plus cos square a plus 2 sin a cos a is equal to m square. A plus b whole square I have used. This portion becomes a 1. 1 plus 2 sin a cos a is equal to m square. 2 sin a cos a is equal to m square minus 1. Okay. So this portion sin a cos a is equal to m by n. 2 m by n is m square minus 1. So 2m is equal to n into m square minus 1. Okay. So this is it. So we have got what we wanted. Question number 6, and z is equal to r sin a. Okay, r cos a is cos b, r cos a cos b. Show that x square plus y square plus z square is equal to r square. Now I have x square, y square, z square, so I will also square. R square cos square a cos square b. Okay, y square is r square cos square a sin square b, and z square is r square sin square a. Now I will add them. X square plus y square plus z square is equal to r square cos square a cos square b plus cos square a sin square b cos square a sin square b plus sin square a sin square a. That is equal to r square. If I take cos square a common, okay, cos square a common, then I have cos square b plus sin square b, okay, plus sin square a. That gives me r square, this becomes a 1, cos square a plus sin square a, okay, that is again a 1, so r square. So x square plus y square plus z square is equal to r square, okay. So that is their answer. 7th question. Okay, so now this is the 7th question, last sum of the exercise. I need one m square, I need one n square. So I will just get that. Yes, cos square b is m square, cos square a by sin square b is equal to n square. Okay, and then m square plus n square. So I will add these two. M square plus n square is cos square a cos square b plus cos square a sin square b. Okay, now that is equal to, this is cos square a 1 by cos square b plus 1 by sin square b. Okay, I have just taken the cos square a common. Now I will further simplify this. Cos square a, okay, and here I will get sin square b plus cos square b. Note both are b, okay, sin square b cos square b. Okay, so I did one LCM addition. So here this became 1. Cos square a is sines by sin square b cos square b. So nothing is cancelling from here. That is equal to m square plus n square. I have to bring it to this statement. How will I bring it? M square plus n square, if I multiply this cos square here. Okay, so I'll just erase it and I'll write down the final statement here. M square plus n square into cos square b. Cos square b is equal to n square. Okay, so this is m square plus n square, m square plus n square. Okay, now if in order to get this, I will multiply this cos square with this, m square plus n square into cos square b. That is equal to cos square a by sin square b, and that is equal to cos a by sin b is n square, because cos a by sin b is n. Therefore, m square plus n square cos square b is equal to n square. Okay, so I finally get my answer, which is exactly that. So with that, we have come to the end of this video. We did question number 2. We did all these type of questions from trigonometric identities. Okay, so If you have liked the video, do not forget to like, share and subscribe. Also, leave a comment behind. I would like to listen from you. If you have doubts in any particular topic, you can tell me that in the comment section. Okay, so please check the playlist. There's a separate playlist for maths topics and physics topics for ICSE. Bye then.